Hey, how's everyone doing? We're going to continue on here with our Algebra 2 linear equations. This is section 2.4 now in the book. Our essential question today is, why are there different equations and how are slopes related? Okay, you know, it's not, the equations aren't always written in y equals mx plus b form. We try to get them there, and I try to use that as a standard for what we use. But you know, they always come, they look different, and I'll look at a couple of those examples here as we go through. But you know, how do you write the equation of a line? We talked about it last time. We're going to kind of stay with y equals mx plus b. To write the equation of the line, you need to know the slope m, and you need to know the y-intercept b. If you see where the graph is crossing the y-axis, that point where it crosses the y-axis is your b. Or if they give it to you like, and they tell you a point is 0, 6, then 6 would be your b because x is 0, and on the y-axis x is 0. So they can give it to you that way too, and you'll see some examples of that in the classwork. A couple different examples of how it can be presented. I gave you one like this on the last notes. If you're given the slope is 5 and the y-intercept is 0, 2, they're giving you m is 5 and they're giving you your b is 2. Okay, so you just plug in your m and your b, remembering that x and y are points on the line. Okay. Second example. Here they give us a point. They tell us that our line goes through the point -4, 1, and the slope is -1/2. Okay. So how do we write that equation? We know our m, but we don't know our b, so we have to find it. So we take our -4, 1. Remember, I said it's a point on the line, so it's x, y. And we plug the points into y equals mx plus b. You can see here I plugged in my y, my m, my x. There's my b. Solve it just like we did in the last chapter when we solved for a variable. -1/2 times a -4 is +2. Subtract it over. Your b is -1. So now we know m, and now we know b. Then just plug them into the equation. There's my m, there's my b. That's the equation of the line that goes through the point -4, 1 and has a slope of -1/2. Okay? The third type of example we could get is this right here, where all they give us are 2 points on the line. Now remember, I told you you need to know m, the slope, and you need to know b, the y-intercept. If we have 2 points, we can figure out the slope. Remember we talked about this in the last lecture? To find slope, we call that x1, y1. We call that x2, y2. And we can plug them into the formula for slope and figure it out. So m is going to equal 8 minus 2 over 5 minus 3. 6 over 2, our slope is 3. Okay? Now, I'm where I was on the last example. I know 2 points, I can just pick one. I'll pick this point right here, and I know my slope. So I'm going to take those both, and I'm going to plug them into my y equals mx plus b. And I'll find my b. Okay? There's my x, there's my y. My m is 3, my x is 3. Find b. That's 9, subtract it over. So -7 is my b. So y equals 3x minus 7. That's the slope of the line that goes through those 2 points. Okay? 3 different examples. One of them they give you m and b, plug them in. One of them is a point and the slope. Plug the x, y, and the m in there and find b. Or if they give you 2 points, find the slope, and then do like the second example. Okay? Another way that we see from time to time an equation written is in standard form. Okay? Standard form is ax plus by equals c. An example of that, I'll show you an example of that. We're going to start off with y equals our mx plus b form and write it into standard form for this example. Okay? Now, one thing you want to kind of make note of right here is when they give us an equation with a fraction in it, we want to get rid of that fraction if we want to deal with standard form. Standard form doesn't have the fractions in it. And the way you do it is whatever the denominator is, in this case it's 4, then multiply everything in that equation by 4. So 4 times y gives me 4y. 3/4 times 4, the 4's cancel to 1, I get 3x. and 4 times the negative 5 is negative 20. I just distributed it all the way across there, okay? And then just, in this case, subtract the 3x over. It's like those literal equations that we did last chapter. So negative 3x plus 4y equals negative 20. That's that equation that's in slope-intercept form, written in standard form, okay? And then the last example is going the other way with it. If we have an equation in standard form, let's write it into y equals mx plus b form so we can graph it. Now if you look in the book, in the second part of 2.4, it talks about taking this equation and graphing it by x and y intercepts, which works perfectly fine. I've always found in the past that people get confused on when to use it, so like I had mentioned in the last video, I'm going to try to stay with y equals mx plus b and see if we can't just get good at one thing. Okay, so I take this equation here, I want to solve for y, just like we did in the last chapter. Subtract the 3x over. You can't actually subtract them because they're not like terms, but I can write it out like this. And then divide your 5 out. So there's our equation in y equals mx plus b form. There's my y-intercept, plot the y-intercept. There's my slope. And again, when I move slope, I keep my, if I have a negative slope, I want to put it in the top, in the numerator. So I'm always going to go up if it's positive, down if it's negative, and then whatever's in the bottom, I always go to the right. I do that all the time. There's different ways to do it, and they work, but this works for me, and I'll just use one way, so I try not to confuse you. I know I have a negative slope, so my line better go down as I go to the right. So there's my y-intercept 3, down 3 to the right 5, down 3 to the right 5. There's my second point, 2 points to find a line, boom. There's the line for that equation. And remember what the line stands for. You can take any xy point off that line, plug it into the x and y here, and this side will equal 15. 15 will equal 15 for any point on that line. Okay, that's what the line does. Remember, line is just a series of points. You remember that from geometry. So any point off there plugged in for x and y will give you a true statement. You'll get 15 equal 15 in this case. Okay. The last thing we talked about in our essential question was slopes. Parallel and perpendicular lines. Okay? If we have parallel lines, you're going to find that the slopes are the same. And it kind of makes sense. If I've got this going here and they're going the same way, they have the same slope. Same slope. Okay? So if you're looking at two equations and the slopes are the same, you know those two lines are parallel. They're going to cross the y-axis at different points, which they should. Okay? But they're parallel. The slopes of perpendicular lines, remember the upside down T is perpendicular. Your slopes are negative reciprocals. So if I have a slope of a half here and negative 2 here, remember negative reciprocal, negative means change the sign, reciprocal means flip it. 1/2 flipped and change the sign is negative 2. That's exactly what that is. So when you get that relationship, then you have two lines that are perpendicular. Okay? They're going to cross, boom, perpendicular. Okay? Hopefully that's been helpful. As you go through here, pause this thing, write your notes down, play it, write down any questions or anything else I might say that adds to your notes. At the end, then maybe just go back and play the whole thing. Okay? Hopefully this has been helpful. We'll talk about it more in class when we get together tomorrow. All right, you guys have a good one. We'll see you in class.